Hey guys, I hope you're doing well today. In this video, you'll find a lesson on the least common multiple, or the LCM. I'll teach you 3 different ways of finding the LCM, how the methods are linked, and how to apply the concept to solve some application questions. The objective of this lesson is to give you a deep understanding of the least common multiple and how to find it efficiently to solve other complex problems. I hope you'll see that prime factorizations not only help us find all the factors of a number, but also can be used to find the GCF and LCM quickly as well. Let's get into it. The first vocabulary word I'll be referring to are prime numbers. Remember, some common prime numbers are 2, 3, 5, 7, and 11. Similarly, I'll be referring to composite numbers. Some common composite numbers are 4, 6, 8, 9, and 10. Remember, all composite numbers can be broken down into prime numbers. We'll be talking about prime factorizations. Remember, prime factorizations are just the multiplication sentences of prime numbers that equal the original number. The prime factorization for 24 would be 2 times 2 times 2 times 3. 2 and 3 are prime numbers, and the product of all of these numbers gets us 24. I'll be mentioning the word factor. Remember, 2 factors of 35 could be something like 5 and 7. Across different numbers, we can have common factors. Some common factors between 12 and 18 are 1, 2, 3, and 6. While different numbers can have common factors, there's always going to be a greatest common factor. In the list of common factors for 12 and 18, 6 would be the greatest common factor. That brings us to our first new vocabulary word, which is common multiple. Well, first, what are multiples? Let's consider the number 3 here. The first few multiples of 3 are going to be 3, 6, 9, 12, 15, and 18. The list of multiples of 3 goes on forever. While 3 has a limited number of factors, it has an infinite number of multiples. How about the number 2? Well, 2 has multiples as well. The multiples of 2 are going to be 2, 4, 6, 8, 10, 12, and so on and so forth. Every number has an infinite number of multiples. Since numbers have an infinite number of multiples, it would be impossible to find the greatest common multiple. That being said, it's more useful for us for finding the least common multiple. Here we can see that 6 are common multiples for 2 and 3. In addition, 12 is another common multiple. It turns out that 2 and 3 will continue to have common multiples at 18, 24, 30, 36, and so on and so forth. If you're not sure why, pause the video real quick and think about why they continue to meet at 18, 24, 30, and 36, and so on and so forth. There's a very good reason why they continue to meet each other over and over again. That concept brings us to the least common multiple, or the LCM. It turns out that 6 is the least common multiple in this example. Not only does the 6 tell us that 3 and 2 meet at 6 for the first time, but it also tells us that 3 and 2 will continue to meet every 6 after that. I guess we could say that the multiples of the least common multiple will continue to be common multiples of the original numbers. Now that's a mouthful. Now that we've discussed the background on vocabulary, let's talk about them in the context of actually finding the least common multiple. I'm now going to show you how to find the least common multiple using 3 different methods. The first method I'm going to share with you is called the listing method. We're going to find the LCM of 12 and 16. When using this listing method, we start off by listing all the multiples of each number. To get the first few multiples of 12, you start with the number 12 and keep adding 12 to it. You can get the first few multiples of 12 by multiplying 12 times 1, 12 times 2, 12 times 3, and so on and so forth. Similarly, we can get the first few multiples of 16 by repeatedly adding 16. While 12 and 16 have their own multiples, they will eventually always share common multiples. Here you can see that 48 and 96 are 2 common multiples for 12 and 16. Since 48 is the first time these numbers meet, we call this the least common multiple, or the LCM. While 96 isn't the least common multiple, it's still a common multiple. What's cool is once you find the first time 2 or more numbers meet, it's very easy to find out each additional meeting point. In this example, we found out that the LCM was 48. It turns out that all the other common multiples for 12 and 16 are going to be just multiples of 48. 48 times 2 is going to get us 96. 48 times 3 is 144. 48 times 4 is 192. And so on and so forth. In summary, 12 and 16 meet at 48 for the first time and continue to meet each other every 48 after that. While this method is pretty easy to understand, you can imagine it could take a long time if the numbers don't meet each other for quite a while. That's where the next method comes into play. Our good friend prime factorization. Here, I'm going to show you how to find the least common multiple using the prime factorization method. Now I'm going to assume you already know how to find prime factorizations and the GCF. If you need to brush up on it, please watch one of my previous videos on those topics. The prime factorization for 12 is 2 times 2 times 3, and the prime factorization for 16 is 2 times 2 times 2 times 2. Try to recall that when you take the common prime factors and multiply them together, you'll get the GCF. In this case, the GCF would be 4. However, we're not looking for the GCF, we're looking for the LCM. Well, it turns out if you take the GCF and multiply it by all the numbers that didn't match, we get the LCM. The LCM will be the product of all of these numbers. So 2 times 2 is going to be 4, times 3 is 12, times 2 is 24, times 2 is 48. Here we find the LCM is 48. Notice how we didn't have to list out any multiples and we were able to just use the prime factorization. Not only were we able to find the least common multiple quickly, but we were also able to find the greatest common factor along the way. Simply put, we first find what's in common and multiply them by the rest of the numbers. This method is much more useful for larger numbers. Let's bring back the good old ladder or the cake method. Just like how this was the quickest way of finding the GCF, it also happens to be the quickest way to find the LCM. Start off by writing the numbers next to each other and coming up with one common factor. Since they're both even numbers, I can easily tell that they're both divisible by 2. On the left here, we'll write the common factor. Below, we'll divide the original numbers by the common factor. 12 divided by 2 is 6, and 16 divided by 2 is 8. On this next step of the ladder, we try to find another common factor for 6 and 8. Since they're both even numbers, we can choose another 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. Since these bottom numbers are 3 and 4, we notice that their greatest common factor is 1. When the greatest common factor is 1, we call 3 and 4 relatively prime. They can't be broken down anymore. Remember from our last lesson that if you multiply these numbers on the left side, you always get the GCF. 2 times 2 would be 4. What I didn't tell you was what happens if you multiply all the numbers along the outside here. If you multiply this 2 by 2 by 3 by 4, you get 48. Think of this L as the LCM. To give you some more verification, notice what happens if we multiply 16 by 3. 16 times 3 is 48, meaning that 48 is the third multiple of 16. Similarly, if you multiply 12 by 4, you get 48. 48 is the fourth multiple of 12. Just like the prime factorization method, the first step here is to find the GCF, and second, find the LCM. While you can find the GCF without finding the LCM, you can't really find the LCM without finding the GCF first. Notice the similarities between the prime factorization method and the ladder method. The first pair of 2's that match in prime factorization is the same 2 I write on the first step of the ladder. The second pair of 2's I found in the prime factorization method represents a second 2 on the second step of the ladder. This unpaired 3 in the prime factorization matches the unused 3 in the ladder method. Last but not least, these two 2's that were unpaired from 16 represent the leftover 4 in the ladder method. Keep in mind that the ladder method is just an abridged version of the prime factorization method. Here's some visual geometric representations of the least common multiple. In this top example, you can see we have blocks that are length 4 and length 5. It turns out that the LCM of 4 and 5 is 20. Notice here that it takes 5 of these top blocks to reach this distance. On the other hand, it only takes 4 of these bottom blocks to reach the same distance. We call 20 the least common multiple because it's the first time they meet evenly. If these rectangles don't make so much sense to you, try thinking about lights. Imagine a first light will blink every 4 seconds, while a second light will blink every 5 seconds. Assuming they just blinked at the same time, when's the next time that they will blink together? It turns out that the lights will always be blinking at different times until the 20th second. At 20 seconds, these two lights would blink at the same time. Subsequently, these lights will continue to blink at the same time every 20 seconds. Down here, we have a very similar example with some larger numbers. It turns out that the LCM of 12 and 15 is 60. Here we can see that it takes 5 of these 12s to reach 60. By that same logic, we can see that it takes 4 15s to reach 60. It's helpful to note that the larger number will always reach the LCM before the smaller number does. Let's think of a slightly different example here. Imagine that you clap every 12 seconds. On the other hand, your friend is going to clap every 15 seconds. When's the first time you're both going to clap at the same time? That's what we're solving for when we're talking about the LCM. The first time you and your friend will clap at the same time is at 60 seconds. Afterwards, you'll continue clapping differently, but then clap again at the same time at 120 seconds. Every 60 seconds, you guys will clap at the same time. no more and no less. At this point, it's my hope that you have a general understanding of how to find the least common multiple. The rest of this lesson is going to be dedicated to doing some examples together. To get the most out of this lesson, I suggest getting out something to write with as well as something to write on. Pause the video whenever necessary, but try solving these problems with me. When I ask you to pause the video, I'd like you to do so and try the practice problems as well. In example 1, we're going to practice finding the LCM by listing multiples. Feel free to pause the video whenever you need to. Here, we're going to find the LCM of 6 and 8 by listing multiples. Let's start by listing the multiples of 6. Pause the video and write out a few of them. We should have 6, 12, 18, and 24. While we can keep listing these for quite a bit, I'm just going to write 4 for now. Then, let's write some multiples for 8. So multiples of 8 are going to be 8, 16, 24, and 32. After just writing a few multiples of each number, we've already found the LCM. The first multiple we find that they have in common is 24. 24 is the least common multiple. While 24 is the first time these numbers meet, they will continue to meet again at 48, 72, 96, and every other multiple of 24. Pause the video and try to write out some multiples for 12. There's 12, 24, 36, and 48. Then start by listing a few multiples of 10. 10, 20, 30, and 40. Notice here that after listing 4 multiples, we haven't found the LCM yet. Now, while multiples of 10 are always going to end in 0, we should keep listing multiples of 12 until we end in a 0 as well. The next multiple after 48 is going to be 60. 60 is definitely a multiple of 10, so we know we can stop here. After 40 we have 50, and after 50 we're going to have 60. While these multiples go on forever, we don't need to keep listing them because we found our least common multiple. The LCM for 12 and 10 is going to be 60. The next 3 times that 12 and 10 are going to meet are going to be at 120, 180, and 240. Now that we've completed a couple examples together, I'd like you to try a couple on your own. Pause the video now and try to find the least common multiple for 15 and 9 by listing multiples out. Don't stop until you find the least common multiple. If you got 45, great. 45 is the LCM for 15 and 9. Let's just try this method one more time. List the multiples for 18 and 12 until you find their least common multiple. Pause the video now. I hope you got 36. Turns out that 36 is the LCM for 18 and 12. As numbers get larger, listing multiples becomes more and more tedious. In example 2, we're going to practice finding the LCM using prime factorizations. In this first one, we're going to find the LCM for 24 and 20. Let's start out by finding the prime factorizations for each number. Pause the video now and try to find the prime factorization for 24. 24 can be factored into 2 times 12. This 12 can be factored into 2 times 6, and the 6 can be factored into 2 times 3. This factor tree helped us find out that the prime factorization for 24 is 2 times 2 times 2 times 3. Next, let's find the prime factorization for 20. 20 factors into 2 times 10, and 10 can factor into 2 times 5. Here we found that the prime factorization for 20 is 2 times 2 times 5. Now that we found their prime factorizations, we see which prime factors they have in common. Since they both have a 2, I'm going to write it down once. Since they have another 2, I'm going to write that one down. Since they have nothing else in common, 2 times 2 would get us 4, which is the GCF. Since we're finding the LCM, we're going to use these extra numbers that weren't used before. We'll take the 2 2's we found that they had in common and multiply them by these leftover numbers. Here we can see that 2 times 2 gets us 4, times 2 is 8, times 3 is 24, times 5 is going to be 120. The LCM for 24 and 20 is 120. While we could have listed multiples out, this method is much more efficient. Now let's try finding the LCM for 36 and 10. If you're feeling comfortable, feel free to pause the video and try it on your own. If you'd like to do it with me, that's fine too. Let's start off by finding prime factorizations for 36 and 10. Pause the video to give it a try and check it with me. To start off, 36 can factor into 6 times 6, and each of these 6's can factor into 2 times 3. From this factor tree, we can see that the prime factorization for 36 is 2 times 2 times 3 times 3. Now let's find the prime factorization for 10. 10 just factors into 5 times 2. The prime factorization for 10 is simply 2 times 5. Let's see what they have in common. It looks like the only common prime number they have is 2. Let's take that 2 and multiply by all the other prime numbers that weren't involved yet. The product of all of these prime numbers will get us the LCM. To multiply things a little bit easier, I'm going to start off by multiplying this 2 and this 5 together to make 10. 10 times 2 is going to be 20, 20 times 3 is going to be 60, and 60 times 3 is going to be 180. The LCM for 36 and 10 is 180. While we only would have had to list 5 multiples of 36 to get to 180, we would have had to list 18 multiples of 10 to get to 180. This prime factorization method is much more efficient. Now it's your turn. I'd like you to find the LCM for 25 and 15 by using prime factorizations. Start off by finding prime factorizations for 25 and 15 and use those prime factorizations to find the LCM. If you can find the prime factorizations mentally, great. If you need to, make a factor tree. Pause the video now and give it a try. Unpause when you're ready to see the solution. The LCM for 25 and 15 is 75. And let's just try one more time. I'd like you to find the LCM for 16 and 20 by using the prime factorization method. Pause the video now and give it a try. Unpause it when you're ready to see the solution. The LCM for 16 and 20 is 80. At this point, you have 2 methods under your belt. In example 3, we're going to practice finding the LCM using the ladder or the cake method together. Let's give it a try. Remember how the ladder method works. We begin by writing the 2 numbers side by side. We create a step of the ladder and try to think of any number that goes into both 18 and 16. Since they're both even numbers, we know that they're both divisible by 2. Let's put a 2 out here on the left side. If we divide 18 by 2, we're going to get 9. And if we divide 16 by 2, we're going to get 8. Since 9 and 8 are relatively prime and don't have any other common factors besides 1, we're going to have to stop here. While 2 is the GCF, that's not what we're looking for here. Remember, if we multiply all these outside numbers together, we're going to get the LCM. To get the LCM of 18 and 16, we're going to have to multiply 2 by 9 by 8. 2 times 9 is going to get us 18, and 18 times 8 is going to get us 144. The LCM for 18 and 16 is 144. While 144 is the 9th multiple of 16, it's the 8th multiple of 18. Let's try one more together before you try some on your own. Try setting up the ladder method for 42 and 56. Pause the video to try it out and unpause it when you're ready to move on. Again, we're going to write 42 and 56 next to each other and create a step of the ladder. Give yourself some time and try to think of a number that goes into 42 and 56. The first number that comes to mind for me is going to be 7. I'm going to put a 7 here on the left side because it's a common factor. 42 divided by 7 is going to be 6, and 56 divided by 7 is going to be 8. Since 6 and 8 still have a common factor besides 1, I'm going to make another step of the ladder here. A common factor that I can think of for 6 and 8 is going to be 2. 2 goes into 6 3 times, and 2 goes into 8 4 times. I can't make a third step of this ladder because 3 and 4 are relatively prime, and their GCF is 1. And the product of these outside numbers is going to get us the least common multiple. 7 times 2 is going to be 14, 14 times 3 is going to be 42, and 42 times 4 is going to be 168. The LCM for 42 and 56 is 168. Here we can see that 168 is the 3rd multiple of 56, while being the 4th multiple of 42. Now it's your turn. Set up the ladder method to find the LCM for 48 and 36. Pause the video now and give it your best shot. When you're ready to see the solution, unpause the video to see how you did. The LCM for 48 and 36 is 144. And here's one more. Find the LCM for 30 and 18 using the ladder method. Pause the video now and give it a try. Unpause when you're ready to see how you did. The LCM for 30 and 18 is 90. 90 is the first time that these two numbers meet. At this point, we've gone over 3 different methods for finding the LCM. In example 4, we're going to find the LCM of 3 different numbers. Pay close attention to this method because it's a little bit different than the typical ladder method. When finding the LCM of 3 or more numbers, there's a little bit more to think about. Here we're going to find the LCM for 30, 24, and 18. To begin, we got to think of a number that goes to all three of these. The first number that comes into mind for me is 6. I'm going to put a 6 on the side here. 6 goes into 30 5 times, 6 goes into 24 4 times, and 6 goes into 18 3 times. If you weren't thinking 6, that's perfectly fine. You could have also chosen 2 or 3. Afterwards, you would have had to use the other number, which then ends up making 6 anyway. At this point, we look at this 5, 4, and 3 and try to think of a number that goes into all three of them. Since I can't think of any common factors for all three, I think that they are relatively prime. The added layer to finding the LCM of 3 or more numbers is now we have to check to see if there's any common factors for just 2 of the numbers. Since 5 and 4 are relatively prime, we're good there. Since 4 and 3 are also relatively prime, there's nothing we can do here as well. Last, we check to see if 5 and 3 are relatively prime. Since 5 and 3 also happen to be relatively prime, we're done here. The product of these outside numbers is going to get us the LCM. 6 times 5 is going to be 30, 30 times 4 is going to be 120, and 120 multiplied by 3 is going to be 360. The LCM for 30, 24, and 18 is 360. Let's try another one together. We'll start off by writing 12, 9, and 18 next to each other. We'll create our first step of the ladder and think of a number that goes into all three. 3 goes into 12 4 times, 3 goes into 9 3 times, and 3 goes into 18 6 times. Looking at 4, 3, and 6, they're relatively prime. There's no number besides 1 that goes into all three of them. At this point, we're going to check to see if there's any common factors between just 2 of the numbers. Since 4 and 3 are relatively prime, we can't do anything there. However, 3 and 6 have a common factor that we could use. Similarly, 4 and 6 have a common factor we could use. It doesn't matter which one we do first because we're going to end up doing both of them anyway. I've decided that I want to use the 3 and the 6. A common factor for 3 and 6 is going to be 3 here. 3 goes into 3 1 time and 3 goes into 6 2 times. Since this 4 wasn't used here, we're just going to bring it straight down. I'm going to create another step of this ladder because I still think there's a common factor between 2 of the numbers. When looking at 4 and 2, we notice that they have a common factor of 2. I'm going to put that on the side here because 2 goes into 4 2 times and 2 goes into 2 1 time. Since this 1 wasn't used, we're just going to bring it straight down. At this point, we know we can stop. The 3 numbers are definitely relatively prime with each other, and every possible pair of numbers are also relatively prime. If that's the case, we don't need to keep going anymore. The LCM is going to be the product of all of these outside numbers here. 3 times 3 is going to get us 9, 9 times 2 is 18, 18 times 2 is 36, 36 times 1 is 36, and 36 times 1 is 36. The LCM for 12, 9, and 18 is 36. Now it's your turn. Pause the video and find the LCM for 8, 12, and 15. Use the ladder method. Remember, first see what number goes into all 3 numbers. Once you can't find any more numbers that go into all 3, it's your job to check to see what number goes into just 2 of the numbers. Whichever number doesn't get used, just bring it straight down. Repeat this until you can't find any common factors between any pair of the numbers. When you're done, multiply all the outside numbers to get the LCM. Pause the video now and give it a try. Unpause when you're ready to check your answer. The LCM for 8, 12, and 15 is 120. Pause the video and give it a try one more time. Here, you're going to find the LCM for 16, 6, and 24. Pause the video and use the ladder method. Unpause when you're ready to check your answer. The LCM for 16, 6, and 24 is 48. Here, we're going to try some application word problems. In this first example, an Amazon delivery truck is trying to maximize the amount of packages packed into the truck. There are 2 different size boxes that need to be delivered. One has a height of 15 inches and the other has a height of 12 inches. If kept in separate piles, what's the least height which the 2 piles will be the same height? First of all, we want to notice that there are 2 key words that let us know that this is an LCM problem. The words least and same give it away that we're looking for the least height which the packages are going to be the same. Since the packages of the same size are going to be stacked on top of each other, they're going to be in multiples of themselves. I'm going to start off here by writing the numbers next to each other and thinking of a number that's a common factor. After writing these numbers next to each other and creating my first step, I'm going to think of a common factor. 3 goes into 12 4 times, and 3 goes into 15 5 times. Since 4 and 5 are relatively prime, we don't have to make any more steps for our ladder. The product of these numbers on the outside are going to get us our LCM. 3 times 4 is 12, and 12 times 5 is going to be 60. So far, we found out that the LCM is 60. While 60 is what we found to be the LCM, we want to make sure we can interpret what that actually means. It turns out that 60 inches is the lowest height in which they'll have matching heights. While it'll take 4 of the 15-inch boxes, it'll take 5 of the 12-inch boxes. Every 60 inches, the 2 stacks of boxes will be the same height. Now it's your turn. I'd like you to pause the video and read the question to yourself. Try doing this problem on your own to the best of your ability. When you think you've got it and you want to check your answer, unpause the video. It turns out, the first day that they're going to all have their activities is the 120th day. Since the LCM is 120, they'll all have their activities every 120th day. In the future, their activities will also coincide on the 240th, 360th, 480th, and so on and so forth days. And here's the very last example of this lesson. Pause the video now and read the problem to yourself. Try solving the problem on your own before you unpause the video to check your answer. Hopefully you found out that both buses will be back at the bus station in 120 minutes or 2 hours. And that concludes this video. I hope you found this lesson useful in improving your understanding of how to determine and utilize the least common multiple. Have a great day, and I'll see you in the next one.